Hi guys, over the last few months, 2 months actually to be precise, I've been building this application, this mobile app called NutriWizard. I've been battling against App Store to finally release it. I released it a few weeks ago and I've been using this app. I find it quite useful and I actually also find the tech stack quite fascinating, at least for me. And I would like to walk you through what it actually looks like, what components I have, how they communicate with each other, and yeah, to demonstrate this all, I prepared a small presentation with all the components, and let me just start with the backend. So the backend uses NTIA architecture, and it actually just means that the application is divided into multiple layers. And the first layer that it has is actually the infrastructure layer. Because in the end of the day, the app has to run on some infrastructure. And if I show it to you in the code, this is what the whole infrastructure layer of this application actually looks like. So we have actually one Docker file, which means it actually doesn't matter what applications we have installed on our machine where we want to run this app, or what libraries are installed there. As long as we have this Docker file and the code of the application, we can run this application. Or as long as we have this Docker image on the machine, we can run this application. So this is the infrastructure layer. Another part of this infrastructure layer is actually this docker compose.yaml file. It's not necessarily needed to run the application, it just describes what services are required to run this application. And currently it only requires a database. Here I use Postgres, and I also have adminer. But again, this docker compose.yaml file is only for development purposes. It just describes what services are required for this application to run, meaning the database. But it also can, for example, you can also start the application environment by running docker compose upd. But again, I'm only using this thing locally, and it starts the database. Now, as you can see, if I run docker ps, here are the two containers that are running, and I can also start the application by running go run main.go. And this is exactly what this Docker file actually does. So instead of go run, we actually build the application and then we run this executable in this environment. Now, this was the infrastructure layer. The next layer that it's so to speak loaded is the configuration layer. So the configuration layer looks like this. In Go, you can actually define your configuration using structs, and then there are certain libraries. For example, I think there are more, but I'm using the library called go.env, and what this library does is it actually just loads configuration from environment variables to a struct. And here, as you can see, what I like especially about this library is that you can have nested structs. For example, here I have a struct called OpenAI, and this struct has this environment variable, or this variable which is loaded from an environment variable. And it's actually loaded like this. So here we have this env prefix, and it's called OpenAI underscore and then API key. So meaning that inside of this .env file, I have OpenAI underscore API key, and its value is actually loaded into this API key. So this was the configuration layer, and now I'm going to show you the persistence layer. So for the persistence, I'm using this Ent library or framework. Yeah, they're calling themselves a framework. So it's actually quite useful because it allows you to also define your models in a declarative way without like manual database migrations. So for example, if we go to model schema, and if I open, for example, the users table, as you can see, all the fields are defined in a declarative way. So this is a string, this is a string, this can be optional and nullable. The ID cannot be optional, it's unique, and stuff like that. And based on this database schema, using code generation, you can actually do go generate model, and it generates all the code here that's required to, for example, do some database operations. And what I also like about this End framework is that it provides you a really great interface to communicate with the database. So let's check, for example, I don't know, this authentication. Not a good example. Let's check this journal. Yeah, that's a good example. For example, if we go to this journal controller, as you can see, this is what the interface looks like now to communicate with the database. And you can be sure that this code is very efficient because it's using code generation behind the scenes. So there's no or very little reflection, for example, in order for these functions to work. And it's a very, very convenient interface to communicate with the database, especially given that you can, for example, have joined tables here. As you can see, I want to query meal entries with custom meal entries, with dish meal entries, and these are all joined tables, and just handles it behind the scenes, which is very, very useful. So this End framework builds my persistence layer, and then there's also the services layer. Now the services layer actually looks like this. Here I have, for example, if I go to services and if I go to LLM, this is, for example, one of the services. I didn't really tell you what the app does. So the app is actually to track your meals and calories on your meals. For example, you're able to make a photo and the AI should tell you what calories or nutritional values your meal has. And then these values are saved to your journal, and you can see, okay, on this day I ate so many proteins, calories, and so on. And for that I'm using, for example, an LLM. And to use an LLM, I'm not just using an LLM inside of a controller. Instead, I define an interface. Here the interface is, I have to find it somewhere. Here it is. Type LLM interface, and here there are just really kind of, I would say, provider agnostic methods and functions. So generate message, for example, there is no kind of mention of OpenAI, for example, or Gemini or whatever. It's really, really provider agnostic. And then what I do is actually implement this interface inside of this file for OpenAI specifically. And the OpenAI specific instantiation is done here in this constructor. So this constructor returns a pointer to the struct which implements the functionality described here. Generate message stream, transcribe audio. Yep. So, and I have a very similar thing, for example, for the bucket. Let's say we have this bucket interface and we want to be able to list the files inside of the bucket, put a file into it, check if a file exists, and so on and so forth. And I have only one implementation for this interface, which is GCP bucket. Now you might be wondering, is it really necessary if we have only one implementation? Because, for example, I don't have like 5 implementations, let's say, and I don't want to inject them conditionally, so it's really not so, it wouldn't be so complicated to just start with the implementation. But I like to start with the interface anyway, because it ensures that my components are loosely coupled with one another. So for example, here inside of this controller, this journal controller, let's say, I have a bucket, and this controller doesn't really know anything about what kind of bucket it is. It just knows, okay, this bucket can actually just, so we can put something inside of this bucket, we can check if a file exists inside of this bucket, we can download a file from the bucket, we can delete a file, but this controller, for example, doesn't have to know anything about what kind of bucket it is. And I really like to keep the components really loosely coupled with one another. So this was the brief overview of the services layer, and then I'm going to go to the presentation layer. So the presentation layer is implemented with the Huma framework. Huma framework looks like this, and what it does is actually very special. When you write your code for the router, so here are my endpoints that I created for this API, and when you do so, you actually get a open API specification pretty much for free. So I'm going to show it. So if you start the application and when you go to this IP address, and it should actually be localhost. And this is what the documentation actually looks like. So I didn't write this documentation, it actually was generated using Huma. And it's really helpful because all the payloads are defined here, as you can see. And what you get back is defined here as well. All the schemas are defined here. And this all is done automatically, just based on my code. So for example, I can show you this DTO, update user in, and based on this struct, this whole documentation is created. Okay, so as I mentioned, I define interfaces first and then I write implementations. And as I also mentioned, code generation is heavily used. I mean, I only mentioned it for End, for this database framework, but it's also quite heavily used for the dependency injection, for example. For dependency injection, I'm using Wire, which is a package from Google. It looks like this. It's actually archived, but it honestly, to me, it doesn't really mean anything because it's just been working. I've been using it for like 1 year, I think, or so. So it's been working all this time, and I also expect it to just keep working because it's not really so special. It just provides a convenient way to inject dependencies into the application. So I'm using this Wire framework, and what it does is, so here I actually describe my providers. So let's say I want to provide a journal controller, which is this one, to the application. So as you can see, it's provided here, journal controller. And what I do is actually I go to this wire.go file and I write a provider, for example, this one, provide journal controller, and I describe its dependencies. And as you can see, it depends on the database and the bucket, and I just provide these things into this controller. So I'm using this constructor. And then I also declare a function, declare this function here in this new set. And then it just takes care of everything. So I'm not going to go deep into it. So if you'd like to check it out, it's actually here, github.com, Google Wire. I really use it in every single project that I do in Go, and I highly recommend it. So yeah, I use CodeGen for dependency injection, and then, by the way, when I write this Wire code, I can just regenerate it using GoGenerate app, because this Wire file is in the app directory here, and as you can see, generated this wire gen file, which is a bit bigger, and it describes then how exactly things should be instantiated. Then I also showed you the persistence with End, and I also have the same thing, also code generation for enums. And here's what it looks like. So for example, I have this, let's say I want to have users and they want to have roles, for example, a user and an admin. And what I want to be able to do is actually I want to see these values in the API documentation when I start the server. And if I refresh this page and if I search here for, let's say, users, as you can see here, when I go to the role, my role can be either a user or an admin. And if I would go ahead and add a new role, let's say, I don't know, guest. And if I save it and if I regenerate the enums and if I run the project again, it takes a while to compile, but then once it compiles, I can go ahead and refresh the page. And if I scroll down, oh yeah, because this is the hosted version, right? If I refresh this page and if I go to get users here, then I'm gonna see, okay, user, admin, and guest. Okay, because this was the already version in the, because this was the version in the cloud, and here's my local version on localhost, right? So, meaning that I also use code generation for enums as well, and this is the code that's generated based on it. So it's actually just some glue code, first of all, for End. So End requires you actually to, in order to be able to use this enum, it requires you to implement this interface, this values function, and in order to see these changes in the Huma documentation or in this open API specification, it requires you to implement this schema interface. So Huma requires you to implement this schema interface, or this schema, this function that returns a Huma schema. And this is what this code gen actually does. And then what else do I have? Okay, wire is used for dependency injection, and the whole tech stack is actually, or the primary components in this tech stack are Go programming language, wire for dependency injection, Ent for database connection, Huma for the presentation layer or API, and Docker as an infrastructure layer. And then we go to the front end. So the front end, nothing really fancy here. What I have is actually PNPM for package management. Then I'm using React Native. To be honest, I haven't put much thought into it, so I might as well use something else like Flutter. And the thing is, I don't really like front-end development, and since I just knew React, it was kind of a no-brainer for me to use just React Native for this project. Then it was also a no-brainer for me to use Expo, because Expo provides you some nice things like Expo Go, and with Expo Go you can pretty much preview your whole application on your phone without really building it. So for example, I'm working on Windows, but I have an iPhone, and I have really no way of previewing my application if I just used React Native. So I had to use Expo to be able to test my application on an iPhone. And then one very important piece is actually this Hey API package, because what it does is it actually allows me to create the client code to communicate with my backend using my open API specification. And the way it does it is actually, if I go to package.json, I have defined the script here, and what it does is it downloads this open API specification from my local server, and using this Hey API package, it generates a client here. And what's great about it, and this is also the reason why I really wanted to have all the values, or all the enum values, very clean here, is that when I generate pnpm run API update v1, when I generate a client to communicate with my backend, okay, now it doesn't work because I might have not, okay, I did start the server, but okay, for some reason, some permissions things, so I can generate it now, but still I generated this like a few minutes ago. And what I can show you is, for example, if I go to, let's say, profile.ts6, here I'm using this getUsers function, and this getUsers function actually corresponds to an endpoint, which is here. So I can always know, okay, this function belongs to this endpoint, and I don't really need anything to call this function. So it's really really simple to use, and so I have all the types from the backend. For example, I have let's say role. What does it have? It has for now admin and user, because I wasn't able to regenerate it now, but still it has all the types that I define on the backend. When I sync the code, it automatically provides all the necessary types that are defined on the backend side. And what else do I have on the front end? Yeah, these are the important details. And what I do, or actually on the side of the architecture, I only store the UUID of the user to be able to authenticate. I store the UUID in, I think it was called Keychain, probably on iOS. So it's a secure storage, and an important thing about it is that it's persistent across app reinstallations, as far as I know. And this is the reason why I store the UUID of the user there, because I want to ensure that I can handle guest users when they first start the app, and that even if the user decides to reinstall the app, they cannot abuse my system. They cannot abuse credits, because their ID stays the same across reinstallations. And yeah, the app, as I mentioned, only stores the UUID, and it communicates with the backend to have all the nice functionality, such as, for example, AI analysis of meals and stuff like that. And then I'm going to go to the overall architecture. So I have a database, and this database is running in a Docker container, which is running on a VM on Linode. And here's what it looks like. Nothing fancy. I use a fairly small node, which I think costs like $36 a month. I might as well switch to a smaller node because, as you can see, I'm only utilizing on average 21% of the CPU, and I don't see how much memory, but anyway, I'm gonna check it later. But in general, Go doesn't actually use a lot of memory. So on this VM, a Postgres container is running, and its container is actually available to the application via a private network, so it's not exposed to the outside world, as I wrote here. And the communication patterns are, so the Expo app communicates via REST API client generated using the OpenAPI specification, and Expo app doesn't communicate directly with third-party services. The communication happens via the backend. Because on the backend side we can check, okay, how many times has the user called this API, and we can constrain the user. And then let me go to the infrastructure aspect of the whole thing. So on the infrastructure side, we have our backend hosting, and for the hosting of the Docker image, or for the storage of the Docker image, I'm using GCP Artifact Registry. GCP stands for Google Cloud Platform, and I'm using this Artifact Registry service to host or to store the Docker image of the app. Then I'm using GCP buckets for file storage, and I'm using Key3s, which is a Kubernetes distribution, to host the backend API and the landing page. The landing page looks like this. It's just a Next.js application, nothing fancy about it, just really a one-pager, I think with some legal pages. So, and this Key3s cluster has only one master node, and it's been working really, really great. So if I check, for example, the database connection, so here's the hosted version. Now if I, for example, refresh the page, it only takes like 55 milliseconds to fetch this thing, and yeah, around about 50 milliseconds. I can't really fetch anything because I have to provide my token, and I don't remember what it looked like, but as you can see, it takes really milliseconds to load, and it's, well, Key3s does this with only one master node and on a fairly small CPU, which is, I think, really a great metric. So we have one master node, it's on Linode, and Postgres is running in Docker on the same VM, so it's literally on this same VM. So we have this NutriWizard master node, and both Key3s and one container with a database are running on this node. And this node, or this database, I mean, has only one container, only one instance, and a mounted volume to really ensure persistence, because otherwise, if we didn't have a mounted volume, then every time I restart the database, it would cause like all users to be deleted, all data to be deleted. And on this infrastructure, or in this infrastructure block, I also described that what external services I'm using. So for example, I'm using an LLM. Here I'm using OpenAI for text-based tasks, and for image-based tasks I'm using some AI model from Google, but I don't really remember which one, for image analysis. And then I also use Aptabase for Expo app analytics, and I use PostHawk for landing page analytics. And this is what my stats actually look like. So I don't really care much about the landing page. It has 43 page views in total, as it seems, or in the last 7 days. Okay, anyway, and 16 sessions. And then what I also have is this Aptabase statistics, which is connected to the application itself. And this is way more valuable for me, because this really tells me what the users do in the application. Where was I? here. So this was my infrastructure, key3s. I also use infrastructure as code. Here's what it looks like. So it's just one repository. We have here my applications. Nginx, I think, was a test. And I have this backend. All the secrets are defined here. And then I have this script that creates a Kubernetes secret, I think, from delete secret. Yeah, it's a Kubernetes secret from this .env file, and all the environment variables for the backend are defined here. And then I have this deployment. I have only one replica. I mount this secret, or I connect the secret, or I pipe actually the secret into the environment variables directly. And I also mount a service account key from Google to be able to communicate with, I think, with GCP storage. Yeah. And then I also have the service, which exposes the backend application in the cluster. And I have this ingress through which users can access the application. And what I also have is actually cert manager for SSL certificate management. And as you can see, for example, if I go to this application, if I check the certificate, it says that it was created on, a few days ago, on the Christmas Eve, pretty much, and it expires in March, in 3 months. So it's handled automatically using Cert Manager. So this was the... Oh, by the way, another thing is that if I log in, or if I SSH into the master node, as you can see, the database container is running here. And in order to be able to connect to the database from this container, I also run this host Postgres service inside of the cluster. I don't really remember how I came to this IP address, but I extracted it from some config from on this VM, and now I can use it as a host from my backend application to be able to connect to the Postgres service, which runs directly on the master node. So this was my infrastructure. And what else do I have? Oh, right. Last but not least, my DevOps stack. So the mobile application, to be honest, it's not deployed automatically. It's still deployed manually. Okay, well, not 100% manually. It's actually deployed via Expo. So basically, I just run one application and the deployment starts. And this is also the way how I submit the application into the App Store. So I also run one command and it submits the application to the App Store. But the backend deployment is fully automated on my side. So here I have this simple build and push image YAML file for GitHub Actions. And what it does is I define all the variables, I check out the code, I set the environment variables, I authenticate on Google Cloud, because as you might remember, I'm using Google Cloud Artifact Registry to store the Docker image. Then I do some setup here, I authenticate again, I set up again Docker buildx command, and then I finally build the image and push it. And here I'm also using GitHub cache to cache the image to ensure it's not like it doesn't take so much time to build it again every single time. And then I restart my Kubernetes deployment. So this is it. Thanks for watching. This is how I built my mobile app.